Hello, I said in the previous class that the one we did last, which is square root and square, is the last lesson. But I just discovered that there is this simple equation with logarithm. We are not going to dive into laws of logarithm. We're just going to look at some simple equation of logarithm, because your teacher will still teach you logarithm on his own. I mean, when you have base 10, all this kind of thing. Apart from this one high take, there's another logarithm which you are going to deal with logarithm with simple equation with logarithm. But I just have to like take you to just introduce you to it. Probably you might have been introduced to it in SS1, but I still feel that let me just refresh your brain on this simple equation with logarithm. Now, let's go. We are going to solve some question, just little question under this thing, then we are done for this particular week. Now, the laws of logarithm, you already know this is log mn. Say log mn. Anytime you have log and there's nothing at the bottom, it is 10. This is log base 10 mn. It's translated as, when you want to split this 10, it means m times, this mn means m times n. So m times n times in logarithm is plus. So it's going to be, we're going to split it. This log times m is log m, plus, instead of now it's times, mn is times, so you put plus in between them, then log n. The same thing if you are giving this one here, you are given something like that. If you want to translate it, you can take it back to this thing. They are interwoven. Now the same thing if you have division, I told you division is minus, so this division is here is what is minus. Then you pick log of what m, then log of what, log of n. Now if you have power, the power is going to move to the front. Then you have your what, log m. So let's look at some questions. Let's assume you are given something like this. They ask to solve something like this. Let's say you have, they said find the unknown. Find the unknown, that is either x or a y, any letter that is attached to logarithm. Now let's say you are given something like this. Say you should solve this. You have 7 equals to log base 2x. They ask us to find x. Now this is what I always tell my students: you change this thing to index form to be easier for you. And when I change it to index form, if this is, you see, anything that is at the base of this log is going to move here. It's going to become the base, while some that is here will become the power, and this x is going to stand alone. Now what am I saying here? This 2 will come here, this 2 here will move here, so you have 2 here. You see this sum that was here before earlier, it will now become the power. Now you are changing to index form. Now this log will be cancelled because what you change now, then you mean only what, only x. Now 2 raised power 7, I think is 128 if I'm not mistaken. 128 equals to x. So that is it. That is that for that one. Let's look at another question. Let's assume you are given something like, said you should find x. You have log x, log base x 64 equals to 2. Now the same thing I'm going to do, I thought that anything that is there will come here, will move here, becomes base, while anything that is here or before will become the power. So this one will stand alone, then the log will be cancelled. So it used to have was 64 standing alone equals to, then the x will now come here, becomes the base, then the 2 will become what, the power. Now what you want to do, you can transfer this square here, becomes square roots, but I would advise you that if you want to make it easier for yourself, make both of them have the same, either the same power or the same base. Now here, it's not possible for you to make them the same base, because this one is a variable letter, this one is a number. So I can make it have the same power. So now you know that 8 squared equals to 64, right? 8 times 8 is 64. Then you have what? You have x squared here. So you can cancel this, because just equation something. So it means my x is equals to what? Or 8 is equals to s, or 8 s is equals to 8. That is that. Now let's look at another one. Let's assume we are given something like this. You have 2 log x, then there's a big bracket here. They give you 3 number, 3 over 8 is equals to, then you have what, 6 here. So how do you solve something like this? The first thing is that you have to change this thing to improper fraction. 8 times 3 is 24. 24 plus 3 is 27. So you have 2 log log x, log base x, then you have what? 27 over 8, right? Something like this. Then is equals to what? Is equals to 6. Now I told you when we were doing this logarithm, I told you that anything that is at the power here, it can come here. The same thing, if you have something like this, it means this, what is the number here, can move here, becomes what? Becomes the power. The same thing I'll do, this 2 here, I can move it here, it becomes what? The power here. That's what I'm going to do. So let's go down. Okay, so once these two move now, I can rewrite this equation as like this: log x, then you have what? 27 over what? Over 8, then you have raised power 2 equals to what? Equals to 6. Now I can do this before I even move anything. Before I move everything, I can take this now. 27 squared, I think it's 729 if I'm not mistaken. 27 times 27 is 729. Then 8 times 8, 8 squared means 8 times, not 8 times 2, 8 times 8, that is what? 64, right? That is that. Then I told you that this, anything that is here will move here, then this log will be cancelled. That this one, it means this one will stand alone. I told you earlier this is going to stand alone. This x will now move here, become base, this one will become power. So we have is equals to, then you have x, then what is here now become what? The power. Now I can't make both of them have the same base. It's not possible because this is a variable letter, this is a number, but I can make them have the same power. When you check very well, you know that 3 raised power 6 will give us 729, and 2 raised power 6 also will give us 729. So I can do something like this: 2, then I will do something like this: 6, because 3 raised power 6 is 729, 2 raised power 6 is 64. Then you have what? S raised power what? S raised power what? 6. Now this 6 can cancel this 6 now. So it means my x equals to what? 3 over 2. That is that. So let's look at another one here. This is the last one here. So I'm not going to go deep into it. There are still some questions here, but I don't want to this is just introduction to it. Now you have, what of if you are given like this: log what? Log x minus log, I think this is a y question, 2x minus 1 equals to 1. Now if you are given something like this, I told you earlier that if you have log is a natural log, it means it has an invisible 10 here. Just note that, has an invisible 10 here, unless you are given another base here. Now what you are going to do, according to our laws of logarithm, you know minus is division. When you check very well, let's go back to that laws of logarithm. You can see minus, you can change it back to what? Log m over what? Over n. So if I want to do this now, I can combine these two values, this value and this value, in logarithm form. So they have the same base, log 10. So I will just write log base 10. So using the laws, minus means division, so I can say x over 2x minus 1 equals to what? Equals to 1. And according to what I taught you, I said anything that is here will come here, become the base, this one become the power. So you are left with only this one. The log will be cancelled. So we have x over 2x minus 1 equals to 10 raised power what? 10 raised power 1, right? So what are you going to do now? 10 raised power 1 is 10. So let me just clean this top number. I think I've copied this from right. You can pause the video and copy it first before. Just want to clean this one so that you can have space to write. Now what I'm doing now is that, okay, now since 10 raised power 1 is 10, 10 raised power 1 is 10, right? So you have x over 2x minus 1 equals to 10. What we do now is what? This over 1, you cross multiply. So you have 10, open a bracket, 2x minus 1 equals to x times, what are you going to add? 10 times 2x is what? That is 20x. 10 times minus 1 is what? That is minus 10, equals to what? Equals to x. What are you going to do? You transfer this one to the other side, you bring this one here. So you have 20x 20x minus x equals to 10, because when 10 comes here, become plus, this one becomes a, that's the multiple plus here, it becomes what? Minus. 20x minus x is what? That is 19x, right? Equals to what? Equals to 10. What are you going to do? You are looking for x, you divide both sides by what? By 19, because 19 is attached to x by 19. So when you just cancel this, so it means your x is equal to what? 10 over what? 10 over 19. That is all. Thank you very much.